Okay, here's warm-up number 13. We're going to write an equation for a reflection of f of x over the x-axis. So when we're going over the x-axis, that's like changing the y-coordinate, and y is kind of the same as f of x, right? So we're going to take the opposite of f of x, okay? I'll get back to that in a second, but the second one we're going over the y-axis, and when you do that, you're changing the x values if you're reflecting, say, a single point. So that means you're going to take the opposite of the input of the x. All right, my phone went off, so I had to make an edit there. But okay, anyway, so the opposite of the input when we're reflecting over the y-axis. Okay, so let's try these out. Here, I'm gonna substitute in all of this for f of x. So I'm going to take the opposite of all of that, and remember to use parentheses when you're substituting, because that's going to remind you that you need to distribute the negative. It's not just putting a negative in front of the 2x squared. We're taking the opposite of the whole function, so we got to change the sign of all of the terms. Okay, so there we go. All right, and then when we're changing the input, we're just changing the x's to negative x's. So let's substitute negative x in both of those positions. Okay, now negative x times negative x would be positive x squared. So this is actually going to simplify to 2x squared, right? And then this would simplify to negative 3x minus 4. And there we go. Okay. All right, next problem. What type of an equation fits the data? Now, notice how the x's are evenly spaced, 1, 2, 3, 4, 5. When that's the case, which it is for both of these problems, this is 1, 3, 5, 7, 9, we can do a little test. So what I can do is look at the differences of the y's. I can think, what would I add or subtract to get from one y value to the next? Okay, so 3 plus something is 6, that would be 3, right? 6 plus something is 11, that would be 5. 11 plus something is 18, that would be 7. And they're called differences because you can always take a number and subtract the previous number. 11 minus 6 would be 5, right? 18 minus 11 is 7. 27 minus 18 would be 9. And we'd be adding 9 to get from y value to y value. So these are called the first differences here, and I'm getting different first differences. But if they were all the same, say I was adding 3 every time, then it would be a first degree equation, which would be linear, because like an x to the first equation, okay, like y equals 3x plus 2 or something like that, okay? But those first differences weren't, they weren't the same. So let's see if we have a common second difference. So now I'm going to look at the differences of the first differences. So I'm thinking 3 plus what equals 5? 5 plus what equals 7? 7 plus what equals 9? And now, hey, I've got a common second difference. These are called the second differences here. Okay, and that tells me that this is going to be second degree. It's going to be a second degree equation, like y equals x squared, which is called a quadratic equation. Okay, now we're going to write an equation that fits this data. So I'm going to write the equation of a parabola that all of these points are on. And there's a number of ways you can do this. You could do it with a system of equations, but a nice quick way to do it is with a graphing calculator. So I'm going to demonstrate that. Okay, I'm going to do a regression, a quadratic regression here, since I know it's a quadratic function. So what I'm going to do is go to the stat menu. There's the stat button right here, and when I hit that, first thing I want to do is edit, as I want to put this XY table into my calculator. So I'm going to hit enter on edit. Okay, and then I've already got some stuff in there. You could go delete them one by one, or actually you can just write over them. But what I like to do is go to the top, and so I'm highlighting L1, and I'm going to hit clear, and then enter. And then all of those get deleted at the same time. Okay, so my XY table is on its side here. So these are going to be my X's in list 1. So I'm just going to put in 1, 2, 3, 4, 5. So I'm going to hit 1 and then enter, and then 2 and then enter, 3, enter, 4, enter, 5, enter. Okay, I got them all in there. then I'll scroll over with the arrow keys to the y's, and I'll put in 3, 6, 11, 18, 27. 3, 6, enter, 11. I'm hitting enter after each one just to input them. I got them all in there, okay? So next up, now that I've got those inputted, I'm going to go back to the stat menu. So I'm going to hit that stat button again. And this time I'm going to go over to calc. I'm in the edit column here. I'm going to go to the calc menu in stat. And I'm going to do a regression, okay? So it's got some different options, a linear regression, quadratic, cubic, quartic. Now I know this is a quadratic function, so I'm going to pick quadratic regression. Okay, so I'm picking that, and then I hit enter to choose it, and then enter once more to actually run the program. And then it's spitting out this information. So it's giving me a quadratic function in this form, and it's telling me what a, b, and c are. So since b is 0 here, there's not going to be an x term, but there is going to be an x squared term and just a constant, the c. So this is going to be y equals 1x squared plus 2, or just y equals x squared plus 2. And you could test it out, right? If you plug in, say, 2 for x, 2 squared is 4 plus another 2 would give you 6 out for y. So it works with all these xy pairs, okay? We're going to do the same thing on the next problem, but first we have to figure out if it's quadratic or something else. So let's look at the differences. So thinking, how am I getting from y value to y value? All right, so here I'd be adding 7, and then adding 7 again. Hey, I'm adding 7 on all of these. I've got a common first difference. So that means that this is going to be first degree, my equation, which is linear. That's a linear equation. So a straight line would fit on all of these, fit all of these data points, okay? All these xy pairs. So same thing again. I'm going to go to stat, edit. I'll just clear. I'm highlighting L1 and hitting clear, highlighting L2. You can write right over them. That's another option. Okay, 1, 3, 5, 7, 9. I just hit enter after each thing. Okay. For my y's, be careful when with the negatives. Don't use the subtraction button. We're not subtracting anything. We're using this negative that's in parentheses that's right next to the decimal point. So I'm hitting -8, enter, -1, enter, 6, enter, 13, enter, 20, enter. Okay. Got it all in there. And I'll go back to stat, over to calc, and then down to, this time it's a linear regression, not a quadratic one, so choose this one and hit enter once more, and then it's giving me a linear equation in y equals ax plus b form. It tells me that the a is 3.5, so 3.5x minus 11.5. So that would be a straight line. All of those xy pairs would be on that line, okay? All right. Last problem. So we've got the path of a rocket is modeled, and if you just think about the path of a rocket, it's going to be something like that, right? Any projectile, assuming we're on the planet Earth, is going to go up and then down. What goes up must come down, okay? So we've got time in seconds is t, and h is height in feet. When will this rocket reach its maximum height? So the maximum height is going to be up here, okay? And remember that your input here is t, so like the x coordinate would be t, the y coordinate would be the height. So this is saying, when is this going to get to the vertex? Well, it's going to get to, so what we're really looking for is the x coordinate of the vertex on this one, right? So you have to be able to interpret this. So we can get that because it's going to be on the axis of symmetry. So you could use the axis of symmetry formula to find the x coordinate of the vertex. It's actually the t coordinate of the vertex here. But so instead of saying x equals -b over 2a, maybe I'll say t equals -b over 2a. Okay? So my b here is going to be 96. So I've got the opposite of 96 over 2 times -16. -16 is the a. Okay? And then, so that's -96 over -32, and that's going to come out to exactly 3. And remember, this is saying when, that's time in seconds, so this is going to be 3 seconds. At 3 seconds, the rocket will be at its maximum height. Okay? What is the the maximum height? Well, that's the h of the vertex. The height is however high it is right here at the vertex, okay? So what I'm going to do, I'm going to find the height when the time is 3. So I'm finding h of 3. In other words, I'm plugging 3 in for t into the original equation. Okay, and then I just have to do the arithmetic here and figure it out. So 3 squared is 9. And then let's see, 96 times 3 would be 288. Okay, negative 16 times 9 is negative 144. And then after you do that addition, we're going to get 144. And this height is going to be in feet. So since this is a word problem, we definitely want our units in there, because that makes a difference. 144 feet, not miles or inches or anything else. Okay, that's it for this warm-up. See you next time.